Walker, preeminent world authority on veterinary matters with pigeons. He's respected all over the world. He's well travelled, he's well versed, he's written books, and his opinions are well respected even where pigeons...
in South Australia.
Even in South Australia. And certainly in Belgium and Holland and the big pigeon places. So feel free to ask at the end of his talk any questions you might have. Ladies and gentlemen, Dr. Colin Walker.
Thank you all tonight for coming, and I'd like to thank the SAHPA and in particular Greg Hamilton for inviting me along. It's nice to see one of my friends, Paul Gardner, has come across from Melbourne just to see me. Maybe not, maybe not. Look, it's interesting, driving here tonight, I was thinking I've been doing these sort of presentations for about 40 years, since I graduated from veterinary school, and I was sort of thinking just how things have changed, because those early presentations, I was a young, keen veterinarian, and we didn't know what we know now, about pigeon racing, and my talks used to be about what causes canker and what causes eye coals. And I sort of think, my goodness, just how the Australian pigeon community has moved on from that. And I'm Australia's representative to the International Pigeon Veterinarians Association, and I think I can fairly confidently say that as Australians we tend to sort of underrate ourselves in a lot of areas. We tend to be sort of world leaders down here, particularly in the vaccination area, and that's what I'm going to talk about tonight. We were the country that did the PMV vaccination trials for zoetis, and so they're a huge international company that gross over $1 billion a year. We did the trials here. We're the only country in the world to develop a subunit. We developed the first ever bird rotavirus vaccine ever in the whole world, and we're still the only one to have developed a subunit rotavirus vaccine, the only one who's ever published efficacy trials for rotavirus and PMV, killed associated vaccines in pigeons, and we're the only one that have a very effective live modified salmonella vaccine. So I think in many ways we tend to be leading the world. We think we're way down here and we look to the Western European countries, but we are doing a lot of good work here. So pigeon vaccination. So it's pretty obvious, but vaccination is the key to preventing some of the most serious diseases of pigeons. That's what we're talking about. Thank you, Gavin. So what do we do? Why do we vaccinate? They're vaccinated to protect against some of the common serious infectious diseases. Vaccination stimulates the body's defence system to build immunity to particular diseases, and we can do that lots of different ways. I guess the older, fairly non-sophisticated vaccines are the pigeonpox vaccine, where it's just a live modified vaccine. So all we've got is a weak strain of the virus that's still alive. When we vaccinate them, we're giving them a mild dose of the disease. The vaccine that we're using now is still the same one that was developed by Arthur Webster in 1954. It's been in use for 70 years. And so very old, but very effective, very safe, vaccine. Or you can expose the pigeon's immune system to a killed organism, so the same organism that's not live, it's killed, and the one that's pretty well used around the world is a killed chicken origin Lesotho vaccine. So that's what we've got here. Or an inactivated organism. So this is where it gets a little bit interesting. The salmonella vaccine that's made in Melbourne, it's really quite natty. So that's a live vaccine, but what they've done is they've genetically modified it. They've knocked out the enzyme so the bacteria can't reproduce itself. And so when we inject the vaccine in, they're getting live salmonella organisms, and this is why the vaccine works so well, because if you're just injecting a killed salmonella vaccine, the immune system's only being exposed to the proteins on the outside of the bacteria, but giving them one of these attenuated ones that lives for just a few hours, where it can't reproduce itself and dies out, it produces the bacterial toxin during that time. So the immune system is exposed both to the toxin and to the proteins on the surface. And when we initially trialled that for Bioproperties, the company that make it, and we were drawing the blood and we sent that down to the University of Melbourne, and they did all the immune studies there, within 8 weeks, the birds on these trials had 3 times the amount of immunity that they needed to protect them from clinical disease. So very safe, very easy, very effective vaccine. We're going to talk about that in more detail. And of course the other one is part of an organism, and that's where the rotavirus comes in. So what the rotavirus vaccine is, that's really a molecular biology vaccine. So you know, we couldn't have done this, you know, 7 or 8 years ago. So the rotavirus, we were able to genomically sequence that, so we get out the whole gene code, and we know what parts of the virus, the different parts of that gene code for. And we know that the part of the rotavirus that really stimulates immunity is just the bit that codes for a particular protein on the virus surface, on the virus capsid, a thing called VP8. And so what we can do is we can just cut out that part of the genome using DNA vectors and just get that part of the DNA to make the protein, which is the VP8, and that's what the vaccine is. We're injecting the pigeons just with that protein that we know is really antigenic. And the natty part is that it's very hard to grow rotavirus, and so after we cut out that part of the genome with the DNA vectors, we put it into an E. coli to make a genetically modified E. coli. And the E. coli is really easy to grow. And so you grow up all your E. coli, that's making the VP8 protein for you. Kill the E. coli, filter out all the rest of the stuff, and all you're left with is the VP8, and that's what you're giving the pigeons, and that's the vaccine. So, what vaccines are available? And some talking points there. So the Poolvac or Nucavac, they're essentially the same. They're killed Lesotho chicken origin vaccines. The bases are slightly different. The Poolvac, I find, is a bit easier to go through a syringe. But we had lots of comments, you know, when it first came out. I remember people ringing and saying, oh, it's just a chicken vaccine, what on earth are we doing? But it doesn't matter what species it's for, you know, and I put the point up there that canary pox has long parts of its genome that are exactly the same as Hendra virus. And so horses are vaccinated against Hendra virus using initially canary pox vaccine. So if you think, you know, God, a canary and a horse, there's a real quantum shift. So it doesn't matter what the vaccine's for, it's the amount of antigenic sharing. And if you're going to get overlap, you'll get cross immunity into the other species. And it was interesting, when PMV first came out, I was the veterinarian in Australia who saw the very first PMV case. And I can remember it was just a weekend, I had the out of hours phone, and this pigeon guy who rang me on Sunday morning, and he said, look, you know, sorry to bother you on Sunday morning, but my pigeons are dying. I thought, you know, this is a very dramatic sort of pigeon guy. But anyway, so I met him down there 2 or 3 hours later, and the long and short of it was that he had 134 pigeons, and in 4 days, all bar 4 had died, and in the next 4 days, the surviving 4 had died. And but at that stage, he'd had about half die, and I thought, I looked at these pigeons, I thought, oh gee, they're not too bad. And so I admitted some, and we did some live bird tests, and I thought I'll you know, do some autopsies on Monday morning. It's not urgent. Came into the clinic on Monday morning, and they were all dead. I thought, Jesus Christ, you know. And we're not that bad, are we? And but the interesting thing was that we collected all the samples, sent off to the lab, and I remember one of the government vets rang me on Friday morning, and he said, Colin, I've got those results back. He said, you better sit down. And he said, Colin, they have Newcastle's disease. So at that stage, it was only New Zealand and Australia in the whole world that was free of NDV, and now it's only New Zealand. So that altered everything. Racing stopped and everything stopped. So that was really quite amazing. But at that time, you know, I didn't know how the government worked, but there's this committee called the CCEAD, Consultative Committee for Emergency Animal Disease. And so this was a big deal because they didn't know whether this new Newcastle's disease strain of virus, you know, paramyxovirus, could affect chickens. And they thought, goodness me, if it affects chickens the same as pigeons, that multi-billion-dollar chicken industry is going to be out of business. And so they wanted to know how they could control that disease in pigeons really, really quickly. And so these 5 experts that make up the CCEAD, we met with them, and the Victorian Chief Veterinary Officer on the Tuesday after that Friday, and they drew up some test protocols. They said, look, we want you as a pigeon organisation to run these trials through. We think, you know, perhaps try this combination, a live vaccine, killed vaccine is what we've got available in Australia, and see if we can get some immunity for you. So that's what we did. And we had 60 pigeons, and we put them in a loft, and we ended up bleeding those pigeons every month for a year and a half, and that's how we have all the information that we have about the immune response to these vaccines. What we found, it actually was a really nice study because it ended up being published in the Australian Veterinary Journal, and Zoetis bought, you know, the rights or the results of that. We'd spent, my time was free, the lab testing had cost about $37,000 to run that trial, and Zoetis, he said, look, we'd like to buy those results from you so we can register this vaccine for pigeons. And I said, well, if you just cover our costs at $37,000, so they ended up giving me $37,000. Then we redistributed that out to the pigeon community in Australia. But what we found was that the two vaccines we had was the killed Lesotho, PMV, and the live modified NDV4. And so we gave NDV4 first, and then the killed Lesotho, and then backwards and forwards, and reverse, and then the two PMVs and the two NDV4s. But what we found was that with the killed Lesotho, the one that we use now, after 4 weeks, 70% had a fully protective level of antibodies. 4 weeks after the second shot, 100% were. With the NDV4, that certainly stimulated an immune response, but it wasn't as strong. Not as many pigeons developed protective immunity, and not all of them, and the immunity they formed wasn't as high. So that's why we have the vaccination protocol we use now. The only other PMV vaccines that are available to pigeon fanciers around the world are live modified PMV strains that come from pigeons. They don't really have any great advantage over the one that we use here, and of course it's illegal to import it, so it's not accessible to us anyway. So the pigeonpox vaccine, everyone's very familiar with that. The salmonella vaccine, I've already discussed how we use that, or what that is. And then of course the rotavirus vaccine that was initially developed experimentally at La Trobe University down in Melbourne has now gone to commercial production at Treadley up in Sydney. So thank you, Gavin. So how do vaccines work? So the first, this is the first injection here, and what it does is it just really primes the immune system. It doesn't really form that much immunity, and the immunity is quite short term. And then so we call that a sensitizing dose, and then it's once you've sensitized the immune system, you then give it the booster, and that's the one that stimulates all the antibodies to be produced and give you your immunity. And that's why boosters are very important, and it's why it's so important they're given at the right time. Because if you give your first one here and then say, oh, you know, I'm busy with other things or whatever, and 8 weeks go by, that's gone. Giving a second shot here isn't a second shot. That's just another first shot again. You won't get that effect. And it's really interesting because, you know, we're learning more and more about PMV all the time, but often you speak to people and say, oh yeah, we vaccinated them, they can't have PMV, but then when you go back and talk to them, you know, the vaccine's been given too young when they're still, the young pigeons' immunity, the development of that is still interfered with by the parents' immunity, and the gaps in that aren't right. So, as I was saying there, so the first dose just sensitises the immune system, and it's the second dose that really stimulates the development of antibodies, and it's the antibodies that stop them getting sick. And as I said earlier, it's the second shot that gives them the long-term immunity. And then, of course, when we were doing that 18-month trial, we didn't know how long the vaccine would work. And so, you know, it ran for 18 months. And what we found is that after 12 months, they were all still immune. The immunity was falling. We were doing these tests called a HIHA test. And in the units we used, they had to be 3 or above to not develop PMV. And some of the birds were as high as 9 and even 11. But what we found after 12 months, even though the levels were falling, everyone was still over 3. So pigeons that had 2 shots 4 weeks apart, both given after 6 weeks of age, 12 months later 100% were still immune. By the 13th month, 10% had fallen below 3. So that meant if the PMV got into the loft at that stage, 90% wouldn't get sick, and the other 10% would show mild signs. They still had some immunity, enough to modify the severity of it, but you'd start to get signs. And with each month, more and more, metabolised their antibodies away, dropped below 3, and became vulnerable to developing clinical disease. So really, just summarising again, so it sensitises the immune system. The second one develops the protective immunity. Immunity lasts about 12 months, and then they have their annual boosters. That's been well published, long time. So what do the diseases that we're trying to protect actually do? So most of you might have seen this, so thank you, Gavin. Of course you're sleeping there. So look, this is a bit of a gory one. So these are some pigeons that were presented, because I'm retired now. If pigeon fanciers ring me, I'm certainly happy to help them over the phone, but I don't have a clinic, so I can't do autopsies or blood profiles. And so I usually refer them to another avian vet, and depending where they are, depends which one. But this was from a one-loft race, and I put him in touch with the closest avian vet, and he took them along, and these birds had PMV. And this bird hadn't died, it had been euthanised, it was still alive, but it was very sick. So what we're looking at here is this is a pigeon's abdomen. That's the heart up here. These are the testicles, that's a cock obviously, and these are the kidneys here. So bird kidneys are pretty amazing because we're mammals, we just have 2 big kidneys. Birds in effect have 6 kidneys. They have 2 kidneys either side, but they're each divided into 3 lobes. And the really dramatic thing with that is that a kidney in a bird should be the same colour as a kidney, like a sheep's kidney that you see in a butcher shop. And when kidney tissue dies, it's replaced by scar tissue. And scar tissue is a creamy, off-white, sort of grey colour. And so you can see there that probably 50% or more of that kidney is now just a creamy, grey tissue. It's gone. And it doesn't grow back. That bird has permanent kidney damage. Its kidney function is permanently impaired. Now, if you have a look at the next one. And this is a really fascinating thing. PMV is the only avian virus in Australia that, for one reason or another, specifically